Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. When Connor rings Ciara's house, the probability that Ciara answers the phone is 1/5. Connor rings Ciara's house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, on the 4th, and the 6th days, but not on the other days. Okay, so let's have a look. So he's ringing her for 7 days, which means I need 7 probabilities. So 1, 2, 3, 4, 5, 6, 7. Find the probability that she will answer on the 2nd. So she's going to answer on the 2nd, she's going to answer on the 4th, and she's going to answer on the 6th, but not answer here, not answer here, not answer here, not answer here. Okay, the probability that she answers is 1/5, therefore the probability that she not answers is 1 minus 1/5, which is 4/5. Okay, probability always has to add up to 1. So find the probability that she will answer on the 2nd, the 4th, the 6th. Okay, and then you just fill in your probabilities. So the probability that she doesn't answer is 4/5. And we want her to answer on the 2nd day and not answer on the 3rd day, answer on the 4th, not answer on the 5th, answer on the 6th, not answer on the 7th. Why and? This is that condition, this is that law of probability. So that's why they're all multiplied. So you put that into the calculator for 8, 12, 16 over 5. So if you put that into the calculator, you are going to get 256 over 78125. Okay. And there was 10 marks for that first piece. So a lot of marks for just that piece. Part B, find the probability that that Ciara will answer the phone for the 4th time on the 7th day. Okay, so again, I have 1, 2, 3, 4, 5, 6, 7 that she will answer. So this is answering on the 7th day. Okay, now she'll answer for the 4th time. So out of these ones here, I have 3 answers. Okay, and there has to be 3 answers if this is going to be the 4th time. Okay, so if I have 3 answers in 6 different placeholders, then I must also have 3 not answers. Okay, do I know the order that they happen in? No. Okay, so therefore the easiest way to do it then is to do 6. So out of those 6 days, those first 6 days, I'd like you to answer 3 times. So for my success, I'm using answer, not, a failure is not answer. Okay, so it's like Bernoulli trial happening here. Ciara either answers or she doesn't. For poor old Connor's sake, we're taking a success to be she answers. So out of those 6 days, we want Ciara to answer 3 times. The probability that she answers is 1/5, and I want 3 of them. The probability that she doesn't answer is 4/5, and I need 3 of them. Okay, remember that these powers must add up to the total number of trials. Okay, so that does this 6 days here. Okay, but of course we want her answering on the 7th day, so I need to multiply that by the 5th. So this one is the 7th day answers, and this is the first 6 days. 3 answers, 3 not answers. Okay, and you put all that into the calculator. 6 choose 3 by a 5th to the power of 3 by 4/5 to the power of 3 by that 5th on the 7th day. So for that, I'm getting 256 over 15625. Okay, so that's the probability that she answers for the 4th time on the 7th day. Connor rings her house once every day for n days. Write in terms of n the probability that Kira will answer at least once. Okay, so from the theory, we know at least once means she could answer once, twice, 3 times, 4 times, 5 times, all the way up to n days. Okay, so at least once can be difficult to get straightforward, but remember that at least once is always 1 minus she never answered. Okay, so the opposite of at least once is she never answered. And if we subtract that from 1, because 1 is what every probability should add up to, then we get this at least once business. Okay, so the probability of her not answering, she never answered, is 4/5. And if she never answered, so it depends on how many days Connor rings. So what is the probability that Kira answers the phone at least once? The easiest way to do it is 1 minus she never answered at all. Okay. Find the minimum value of n for which the probability that Kira will answer the phone at least once is greater than 99%. Okay, now if we're working in ones, because of course probability could be 100%, but my 1 here implies that I'm working in decimal or fraction. So 99% then would be in decimal 0.99. Okay, so find the minimum value of n for which the probability that Kira will answer the phone at least once is greater than 0.99. Okay, right, so let's solve this. So minus 1 from both sides. So I have minus 4/5 to the power of n being greater than minus 0.01. Okay, let's change the signs all the way across because I have a minus here. So that you get 4/5 to the power of n. Now it'll change the direction of the inequality. Why? That always happens when you change the signs on an inequality. So change that sign means you change the direction of the inequality. Okay, then you need, when what you need is in the power, you'll need to use some sort of logs. Okay, you can do the switch. So I'll just come over here, or you could use opposites. So yeah, let me see. I'll show you where I am now. Might be just easier to show you in the log tables. Here. Okay, So you can do the switch up here, which might be the easiest one to do. Okay. Okay. So using this, you can see that A is my 4/5, X is what I'm calling N, and Y is 0.01. So all I'm doing down here is labeling my A, my X, and my A, my X, and my Y. Okay, so then to do the switch then, that becomes the log to the base A, which is 4/5 in my case, of Y, which is 0.01, is equal to X, and X in my case is N. So that's how you do the switch from indices to logs. Log to the base 4/5. Be careful you don't hit the log button in the calculator, because that assumes a base 10. So you're looking for this button, which lets you put in your own base here. So hit that button because your base is 4/5, and then your number is 0.01. Okay, so for that, I am getting 20.6377 being equal to N. So find the minimum value for N that she'll answer the phone so that it'll be greater than 99%. Well, we found it to be exactly equal to 20.63. So you'd need Connor to be calling for 21 days to be sure that she will answer at least once. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.